Hi guys, welcome back to my channel Pirai Academy. In this data structure playlist, today we are going to see about circular queues. So in previous video, we have already saw about queues, right? And we have implemented in two ways. One is array and another one is linked list. In this array, we have two things for the dequeue operation. One is we are just going to do a left shift, which will be space efficient, but its time complexity going to be O of n. And another thing is we don't care of anything, we will be directly inserting it, but its space will be inefficient and time complexity will be O of 1. So there are any disadvantage in these two methods, right? To overcome this disadvantage, we will be either going to the linked list or we can go to the circular queue. Hope you understand this. Okay, so I will be just telling you the ADT of circular queue, and then we can go with the structure of circular queue and its implementation. Okay, so first, what are the ADT of circular queue? As you see, in a normal queue, we have NQ, DQ, and then top or peak. Okay, so these are all same as the normal queues in a circular queue also. Fine. So as you know, NQ means it is inserting an element, DQ means we want to pop an element, top or peak means we want to give the front element. Okay, now let's get started with the circular queue. So let me take these all operations. I assume that you already saw my previous video on queues implementation. If you already saw the queue implementation, circular queue implementation will be much more easier. Okay, so let me take a circular queue. So circular queue will be like something like circle, right? So let me take one circle, then another circle. So just assume this is going to be a circular queue. For a structure, for your easy understanding, I am putting like this. And let us take the size of the circular queue is 5. 1, 2, 3, 4, 5. Okay. Now, this is going to be your starting point as of now. Just assume. The first operation is NQ of 5. So 5 is added. Second operation is NQ of 10. 10 is added. Third operation is NQ of 22. 22 is added. Again 22. 22 is added. Again 100. 100 is added. 23. Now my circular queue is full. How you are telling me that circular queue is full? Because my last inserted values, next value will be 5. Can you understand this? So from this I can tell you that the circular queue is full, so we cannot add this, and we will be displaying a message for the user like, hey, the queue is full, like that whatsoever. And then DQ means I want to pop out the first element, because all the queues have the same thing, first in first out, except the priority queue, that the priority will be the first in first out. Okay, now this 5 will be popped out, and now hats off, now my starting point will be this 10. Can you understand this? Yes. Now if I do a NQ of 23, then 23 will be added here. Yes. Okay, again DQ means this 10 will be popped out and starting point will be something like here. Now again peak means what is my starting point? It is 22. So 22 will be my answer for this peak. Now I want to do DQ for 5 times. When I am doing for the first time, this 22 will be popped out and yes will be now here. Again this 22 will be popped out, yes will be here. Again this 100 will be popped out, yes will be something like here. Again this 23 will be popped out and yes will be going to here. Here there is nothing lies. Can you understand this? When I am doing again a pop operation, the DQ operation, the fifth DQ operation, it will be telling me like, hey, it is empty. Hope you understand this clearly. Okay, so this is going to be your structure of the circular linked list. Now let's get started with the implementation of circular queue. So before this, we have saw about the arity of the circular queue. From this, you can understand the functionality of the queue. Now we are going to the implementation path. So this is not going to be your coding session, rather it is going to be your logical section. Okay, so let me take that same thing. So we are going to do these operations. Okay, now initially I'll be taking a array instead of circular queue. I am taking a array. So in programming languages, they will be already having a library for the circular queue. So now we are going to implement a circular queue using the arrays. In upcoming video, we'll be implementing it using the linked list. Okay. So this is going to be your array of size 5. Assume. Okay. Now at first, enqueue of 5. So obviously we need 2 pointers in queues, because one pointer will be of dq, will be taking account of dq and peak. Meanwhile, other point will be tracking the enqueue operation. So we'll be having 2 pointers. So one pointer is front and another pointer will be rear. Okay, so these both pointers will be lying at -1. So now when I am going to insert this 5 inside, okay, so initially my front and the rear are -1, right? Now this front and the rear will be at 1, will be at 0. Okay, and now this 5 will be inserted here. Okay, now again enqueue of 10. Now I'll be only changing my rear alone. At first only I'll be changing both of them, and in the next steps we will be only changing the rear pointers. Now again 22. So changing the rear pointer and making this as 22. Again 22. Increase my rear pointer and make this as 22. Again 100. Increase my rear pointer and make this as 100. Again 23, which means I want to increase this R to here. Whether it is possible to insert the 23 here, whether it is an empty slot. No, so we cannot do this, right? So we want to add some condition, like if the R plus 1 index is equal to the F pointer index, then we cannot do that. Can I understand this? Here it is 4, right? Now 4 plus 1 will be 5 at this particular index. Now we want to go back to the 0th index, right? So 5 mod 5, which is equal to 0. Can I understand this? Whenever I want to go back to this side, so we will be taking the current index is 5 and the size of the array, do a model operation, so that we will be getting a reminder of which index we want to go. Now the 0th index, I'll be just checking whether the 0th index is my front pointer. Yes. Then what should I do? I cannot add anything. Now I'll be telling that, hey, the circular queue is full. Can you understand this? Okay, now we are going with the DQ operation. Let me again draw this so that it will be more clear. So this is your circular queue implementation using array 22, 22, 100. Okay, now your pointers, the front pointer will be here, rear pointer will be here, right? Fine. Now we are going to do a DQ operation. Whenever we are doing a DQ operation, what will we do? We will be just going with the front pointer and taking this value 5. Either we will be returning it or printing it and make this front pointer to move one step ahead. Now we going with the enqueue operation. Whenever we are going to the enqueue operation, we want to check whether R's next value is equal to F pointer. No. At this particular condition, we again go to the index 0. We again go to the index 0 for this R. Can you understand this? Yes. Now, here we will be replacing this as 23. Now, DQ operation. So, F will be going to here after returning this 10. Okay. Again, peak. Peak means we are just displaying the 22, the front element's value, front index value. So, 22 will be my output here. Now, again, DQ for 5 times. So, for first time, this F pointer will be moving here after returning this 22 or printing this 22. In the second attempt, it will be returning this 22 and moving forward. Again, in the third attempt, the 100 will be returned or print, and this F pointer will be moving to the next step this int is 5, but int is 5 is equal to the length. So you'll be again making my f pointer to move equal to 0. Can I understand this? So f pointer will be moving to here. Okay, here. So let me redraw this so that you can understand this clearly. So here it is 23 and here 10, 22, 22, 100. Okay, 0, 1, 2, 3, 4. Okay, fine. Now just listen this carefully. Now my r pointer is here, my front pointer is here. Again we are going to do a dequeue operation for 4th time. What you want to take care is, see here, my rear pointer and front pointer are at a particular index. Okay, which means it is the last element of my circular queue. So at this point I will be returning this 23 and making my r to -1 and f to -1, so that it implements that, hey, all the elements in the queue is erased, or it is again reset to the starting point. Can you understand this? So now r and f pointer will be pointing towards -1. Now if I do again a dequeue for the 5th time, now my f pointer and r pointer will be equal to -1. So I'll be returning that, hey, the queue is empty. The queue is empty. Can you understand this? Okay. So now let's get with the time complexity for the ADTs. So the ADT here. First of all, tell the time complexity for NQ. It will be O of 1. And then DQ, it also O of 1. Again for top, it also O of 1. And then what is the space complexity? It will be O of n as the user input of the size. Okay. So this is going to be your overall implementation of circular linked list, circular queue. And if you have any doubts, you can comment below. I will be giving you the right explanation for that doubts. And in next video, we'll be seeing the code implementation of this circular queue. If you really like this video and subscribe to my channel, don't skip any videos in this playlist, because all videos will be helpful once you are appearing for the competitive programming. And that's it. Thank you.